in the technical solutions that are being pulled into the projects we work on, but we never know about all of them, in fact. And we get a lot of requests to make testing better, make it go faster, increase the number of tests, reduce the number of tests. A lot of different requests coming into us. So how do we make sense of all this noise? That's what I'm going to talk about today. I'm also going to briefly mention that we came out of a kind of a world where we were using every kind of painful proprietary tool that was written over the past decade. So we're pulling ourselves out of a lot of technical debt. And the main part of this story is how do we do this in a collaborative way? How do we innovate as we're also trying to transform and change? So a lot of challenges, but not totally impossible. So as you may have heard now, you've heard mention of this Eclipse OMR project, this Eclipse OpenJ9 project, and a project called AdoptOpenJDK. So my team of 4 cover testing really for all of that. We've worked in all of those projects, and we're actively working in all of those projects even now. Our goals, of course, are to bring as much of the testing to be open and transparent, and that's easier said than done. We'll talk about some examples of where that's not possible, but really so that the world can be confident in the quality of these JDKs that are being produced. Of course, it's easier to, it's less costly to fix defects when you find them early. So we want to test as low down on the stack as we can. We want to test at different levels. So that we're going to talk a little bit about the layers of testing that we have. And then we also wanted to empower developers. In the past, we've had systems where it wasn't easy to run testing on your laptop. It wasn't easy to set up certain types of testing. So we're trying to make it easier to do that for all people who want to run tests against some of this stuff. And of course, to collaborate and innovate with other teams, we also wanted a story that made it easier to integrate new test material. And that Tetris reference is really true in this story. So as I mentioned, the projects we work at, kind of the mission statement, ensuring free and verified Java for the community, some of the scope. So we're monitoring and we have tests running at more than 6 Jenkins servers at the moment, and that doesn't sound like much until you note that there are hundreds and hundreds of test jobs running on each server. How that multiplies out. So at Adopt, we're not just testing an OpenJ9 implementation. We also test Hotspot. We also test an SAP implementation. And internally at IBM, we test an IBM SDK. So what does this really mean? We also have, by the way, versions. And I'm mentioning the numbered versions here, but in previous talks this morning, you heard that there's Panama, Valhalla, Loom, and Amber. Those are versions to us in our test system. So there are multiple versions that we're testing, obviously many platforms. And those are growing, by the way. When someone comes into the Slack channel at Adopt, hey, can I get this build for something that we don't support, we often add it. So if you have a reason for needing a platform tested, you can actually come and request it, and we'll see what we can do. And then, of course, we have different categories of tests, and we broke it out into these high-level categories, and I'm going to talk about some of that. But before I do, I wanted to also say, looking at the picture of what, how a JDK binary is built, we actually can read this from the OMR side over to this direction and where some of these tests live and what some of these things are doing. So down at the OMR level, and you've heard people mention some of these before, we are doing language agnostic testing. There's a bunch of opcode tests that were put there, IO injection tests, core analytics, and I mention that because you know, some of the testing that we do for the GC, instead of kind of manually creating a GC object model, we pulled the object model out of core files so that we could recreate what a customer's object model looked like. So we took from, you know, core files that were reported on crashes and then took out that object model to create some of the test cases. And then we have applied combinatorial test design specifically, or very successfully, in the RAS test component there. And what that is really reducing radically the number of tests you need to run while keeping the functional coverage fairly regular. And then as we move over, we get into some of the functional and system testing that we have in place. We add some external testing. What I mean by that, and someone asked this morning, do you run Scala on these JDKs? Yes, in fact, the Scala functional test suite is part of the external category that I'm talking about. And we'll look at some of the other stuff there. And performance testing. So this is one where we're actively working on making it easier for anyone to run benchmarks. We're actually putting open performance testing at AdoptOpenJDK, and what does that mean? That means that we'll be able to do side-by-side comparison of a few different implementations of JDKs, and for better or for worse, it will be there for the world and for all developers to see, and we hope that that's going to generate some additional vigor in development. So looking just quickly at some numbers, you can think of us as, at the AdoptOpenJDK project, as curators of tests, where some of the tests come out of, you know, an OpenJ9 team. Some of them come out of the OpenJDK project. There's a large set of system tests, and I'm listing here the unique numbers of unique test cases, not the number of times we grind stuff. So system test is a load and stress framework as well. So we actually iterate 1,000, 3,000, and 300,000 times over some of these tests to try to bring a JDK to its needs. External tests right now, it's 8 applications in their functional suite, plus a bunch, or 3 microprofile QCKs at the moment. And the interesting part about that is we're running those inside of Docker containers. We're doing that for a couple of reasons. One, we want to make sure that the Docker image that's being pushed up to a Docker hub is tested. But 2, we want to be able to see how our JDKs perform this. And then the JDK, that's the compliance test. And finally, the performance benchmarks that I mentioned. So that's a great variety of tests. You can see that they all have their own underlying test frameworks. Is it reasonable for us to expect that developers would actually learn each of these multiple, and I will say probably about 20 different underlying test frameworks? Well, we thought no, because then they'd have to learn the ins and outs of all the different commands and all the different inputs to those frameworks. How can we make the developer's job easier here? As you remember, that was one of our goals. In fact, revisiting the curator's requirements, we wanted the ability to run a lot of different types of tests, the flexibility to bring these tests in. We wanted to make it a common look and feel. We wanted to standardize the actual test output. We wanted to be able to say, you can exclude tests on all those different types in the same way. You can add tests in the same way. And can we make it simple to onboard new people? And in fact, how we did this was we laid a very thin veneer between those underlying test frameworks and the developer or the person who wanted to run the test. So by doing this, what we've done is made it a lot simpler to run an entire suite of tests. And I'm only showing here the top-level test targets, but of course, we made it granular so you can get in at subtests on each of these things, and I'll explain a little bit about that now. So what does this little veneer, I don't call it a test framework, sometimes we refer to it as, but it's not meant to be. We're not in the business of writing new test frameworks. We're in the business of trying to get rid of friction and extra processes and steps. But what you need to be able to invoke this would be some way to tell it how to go and fetch test source and then build it. So for now, that's an Ant script. And some way to say what test targets you want us to generate. And by doing that, we've made it easy. So what that playlist file looks like at the moment, we'll try to continue to simplify it. But at the moment, it's a test case name, so that's going to be the name that gets generated as a test target, and the command you want to run. So in other words, it doesn't matter what you're running underneath, we can capture it and run it here. We also allow for you to be able to say, here, I want to run it with these command line options. And what this does then is the more variations you have, the more times this test will repeat with the different inputs. The additional thing we have, and we needed to switch, so you can notice all this stuff is really just different ways to slice and dice the test. We keep all of the test stuff in one location. One of the options to have managed this would be to have different branches for different versions and all of this. In order to make the developer's job easier, we're taking the hit on this a little bit. But how we do this is allow you to say, if you have a test case that's only suitable to test OpenJ9 SDK or JDK, then you can tag it here. If it's useful to test these, you can put it here. By default, if the test case you're adding can be used against any implementation, you just don't put that tag in there. You'll then generate make targets for all of them. And the same goes for the subsets, so the versions. If you don't say this test is, what if you wrote a test for a Java 11 feature? You would have to put that because it's not present in the earlier versions. But if you don't put those versions in, we'll generate it for all. All right. Finally, levels. So at the moment, we've divided also the test into a couple of different levels. We have a sanity level and an extended level. And the reason to do this is to try to make the sanity level a short, sweet set that could be run quickly. We need to revisit that because it's grown, it's ballooned. November is the month of cleansing, so we'll be addressing some of that. Right now, we also have groups, even though we've divided the functional suite. Those tests actually live in one location at the moment, but we wanted a system that would allow you to lay down tests from anywhere. And TestKit Gen, if you put a directory of tests in the path of it, it's going to go down into all the directories looking for build.xml files and playlist files and run the test. So we wanted to have you be able to still tag it as a functional test if you needed to, even if it didn't live in the functional test folder. So some of you might recognize this as the test, the functional folder inside of the OpenJ9 repo, test functional. Inside there, there's a whack load of functional tests. Inside each one of these folders are build and playlist files telling us a little bit about what you need to do to build them and run those. So I'm going into one of the subfolders, JSR335, and you can recognize that we have those two files that are important to us. There's additionally this, that's another artifact that's needed because those are test ng tests. However, in other cases, like the system test, we don't actually require that. System test uses its own framework. So quickly, I'm not going to go through all the different kinds of tests, but I just wanted to hit on a few of them so people kind of understood how to read and look at the stuff. The external tests live in the AdoptOpenJDK OpenJDK test repo. And inside of the third-party containers test, you can see that we're running the functional suites from Elasticsearch, Derby, Jenkins, Kafka. There's a bunch there, Scala, Tomcat, Wildfly, but additionally we have some of the TPKs. This will grow as we get more machine resources to be able to run these on. Even though they run in Docker, I think we currently only have 3 machines at Adopt with Docker installed, so we're a little bit limited on execution time. Finally, if I had drilled down into one of those examples, you can see that we have the 2 files we require, and additionally we have a Docker file that we're actually building the Docker images as part of the run. What it does is go and pull the image from Docker Hub that was built for whatever versions you have put in your playlist file. And then, so in fact, the power of that is one playlist file lets you test multiple versions really easily and quickly and build Docker images for those. Okay, flying through, I just wanted to do a really short demo of this, and we'll see how this goes. It's a pre-canned demo because I wasn't sure how my network connectivity would go, and I'll see if I can keep up with it. We've set it up. I'm going to go and clone the AdoptOpenJDK test project. And I'm going to lay it down over here. And that gets me all of the metadata for running most of these tests. So that's great. Then I'm going to clone the test kit gen layer plus the functional tests. They happen to live at OpenJ9. So I'm laying that down now. Great. I have most of the things I need now. I'm going to run a get script that's going to go and get me some JDK that I want to test with. I can also just test with any JDK that I've built on my system. Now I'm going to set a couple of environment variables to tell me this specific test run, what do I want to test? I'm testing a JDK 8, and I'm limiting my compile to just the functional suite to make it go faster. Then I'm going to run the configuration step, which actually generates my test target. All right. So, and it actually does go that fast in some cases. The compile, this 8 minutes, is going to look like it's going really quickly, and we should try to reduce our compile to go this quickly. But we're compiling test material at this point. Okay. Finally, I want to actually execute some tests. So in this case, we mentioned you can slice and dice tests. I'm going to say that I just want to run the sanity level test of the functional group. And I can do that by going sanity.functional and blah, blah, blah. Here it goes. They don't actually run this fast in real life. I apologize right now. But you can see that it actually ran 94 tests were executed. Some were skipped. What does that mean? Those were test cases that weren't applicable for this platform, in fact. So this is all well and good. I maybe also just want to run a particular test suite. Inside of the playlist file, each one of those test case name is a suite. And you can see that we've actually got a couple and one that was skipped. If I look at that playlist file, there were 3 variations. One of them was not valid for this platform. If I wanted to run just one of the variations, you just go the name of the test underscore, and then if it was the first in the list, it's numbered 0, 1, 2, 3. And finally, I think this is just showing that you can also run it by directory, and this is really just a feature of Make. But for people who care, oh, I want to just run the test, the JIT test, I can go in there and do that. And I can run just the sanity set or just the extended set. So there's a lot of different ways that you can do this. But not everyone wants to run manually on their machine. So we created not only the nightly jobs and stuff that works as part of pull request testing, but we also created a job called the grinder. And from some of you recognize the name from past days. The grinder actually lets us run those targets in Jenkins, an individual target or even a full suite. You can see random testing. It'll never look kind of even because you could run a whole suite or a single test here. You can run with changes in your OpenJ9 or AdoptOpenJDK repo on all the different platforms we support for all the different versions, implementations, and of course test groups. And in fact, here we're limiting the compile to be just that JIT test folder. And we're picking up the nightly JDK from AdoptOpenJDK rather than uploading a customized build that we have built. And we haven't changed the iterations. We're just going to run this test once. And in fact, we're going to run it on this particular machine. If you don't put anything for label, we'll find a machine that's suitable for that platform. And we run, and of course it runs super fast in demo mode. We're looking again, we picked, I think, float sanity test here, so we'll be able to see in the console output. It's going to look pretty much the same as what you did manually on your laptop. And I wanted to mention that whole test results thing. We wanted to make test results common. Of course, we dump things to console, but we have forced all of these different tests to produce TAP results so that at least we could get a common view across them. If the tests produce JUnit results, we also present that here. I haven't shown it in the demo, but some of these tests don't produce a standard output at all. Perf benchmark system tests don't do that for us. So we force kind of a standard output that could be quickly showing the results. All right, so that's the end of that demo. I just have a few more minutes left here. I think I wanted to come back in just to revisit what we've covered there. So obviously the steps are clone the material and the test kit gen thing, set some environment variables, generate your make targets, compile, execute, and then view the results. We're looking forward on what we're actually going to be doing over the next little while. We're going to be integrating some more testing. So we have some security tests that we're going to be bringing in. And this is the important note about, well, what about if we have tests that shouldn't be open sourced or shared publicly? That's okay. They can live in any internal repo that you have. Stuff that you're not ready to open source or that you have to do some extra legal stuff around, we can run any of it. We don't care. We also have some pull requests about to be merged to actually get some micro benchmarks incorporated in AdoptOpenJDK, plus some full open source benchmark suites. And how do we do it? We bring in that build and playlist files. And looking at the integration example, what this will look like then is, say we have this cool BumbleBench tool created by the JIT team in Toronto, and we want to actually run all of the micro benchmarks that are contained there. Well, all I need to do is in my performance directory, add a BumbleBench directory, include a build and playlist file, and execute the BumbleBench suite. So we'll be adding those to the nightly runs at Adopt shortly, along with some of those other things I mentioned. So what are some other future forward plans that we have? Obviously, we mentioned that number of variations of tests. That actually equates out to nearly 50 million tests that are running nightly around the world. Big numbers are cool, but they're not actually what we're going for all the time. Rather than test more and make the bloat, we want to test smarter. We have some change-based testing ideas in mind that we actually had running internally back when we worked in a Git repo. We'll try to bring those back to life. And a test prediction service. So knowing that more bugs can be found, or more bugs typically happen in source files that are changed more often, we can actually monitor activity and weight the testing to the places where defects are more likely to occur. We want easier reporting, so we're creating some tools for that. We also want to lower the cost for triaging things, and we have created a few tools to make that a little bit easier, and we're going to be expanding or refining some of that. And always, 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 we want to make this easier and easier for people to get involved in because when your team's so small, you really depend on actively engaging other people. The development team is very active in being able to help us, and we want to reduce the friction and the process involved in getting to run these tests so that more people want to help us. Just very quickly, in this final time, I wanted to mention this test result summary service. So because we have multiple Jenkins servers, we didn't create this as a Jenkins plugin, and also because as future has, as the past has shown us, we might change what continuous integration server we're using, so we didn't want to just have a solution for a Jenkins server, but the notion here is we should be able to pull any test results from anywhere, sort them, and let you look at the results in kind of interesting and new ways to make triaging simpler. So I won't show you all of the ways, but first of all, the very straightforward, summarize it for me, give me a few numbers, but then let me look at a particular test target across all platforms or in deep history, and by that I mean we're dumping some of this to a database and letting you compare. This is very important for performance results, I would say. Less important maybe for some of the functional stuff, but of course we can do that as well, especially for intermittent failures. And then finally, be able to show the different variants and see, do we see any patterns in the testing? And I alluded on that other slide to results analytics service. So some of this stuff is not easy to notice by the human eye, but it's certainly easy for some analytics engines to notice patterns. So we are looking at bringing some of that to this tooling in the upcoming months. So finally, last slide. Are our plans really fuzzy? I'll say, no, our plans are clear. Continue to refine, continue to look at new ways to run tests, to include tests, new testing that we can collaborate with other teams on. The future is always going to be fuzzy. It's going to change. We're never going to be able to predict it. So let's have systems that are adaptable and buoyant and kind of resilient to change. I'm looking forward to one of our upcoming collaborations with Dr. Hugh Leather, looking at some fuzz testing. As we mentioned, we want this layered approach. Where can we apply testing to find defects earliest? How can we test in a way that is least costly to our time and to our kind of sanity? So all of the collaborations that are coming up and coming down the pipe, we want to selectively choose things that we think have a big win. And I guess the final note I'll just say is, rather than think of, oh, it's just testing, and I really am glad to see all the speakers ahead of me speaking had mentions of testing in each of the talks. It's very heartwarming for me to see that. I want to bring to our project the most excellent and innovative ways for testing, and that happens through open collaboration. And so I'll look forward to collaborating, connecting with all of you. Right. If anyone had any questions, I don't know how we're doing for time. I'm sorry, I lost. Any questions? Yeah.
But in your communication,
well, in fact, how we do it is we have jobs for all variants, yes. So the whole point is I should be able to input to those jobs. Let me just take a look at, if I could bring up this, how we input those jobs. I should be able to say, I want the OpenJDK regression test for all versions, for all implementations. Right now, how that looks is then I have jobs for 11 and Hotspot, I have jobs for 8 and J9, but the point of it is that I should just be able to pass it in as an input. Why we keep them separate at the moment, and I don't just run this as a big giant, I could run all of the OpenJDK tests for all of the versions in one big run. Machine resources being what they are, we're actually better to split them out into individual jobs because then we allow for the Jenkins queuing to be more efficient.
I just wanted my entry, I perfect one variant because I put my code and I'm assuming it's going to run at every.
Right. So the actual, we want to reduce the number of things you'd have to set. Right now, this is, we've bootstrapped ourselves here. What really we should do is just ask you one thing. Where's the JDK you want to test? So if it's your own personal build on your laptop, you tell us where it is, and then we derive everything else from that.
Figure out
Yeah,
from that.
exactly. Yeah, it hasn't happened yet, but that's part of our, ongoing refinement process. That's on the list. There's an open issue. Yeah. Thanks. Yeah. Anyone else with questions? Yeah.
For the curiosity, how accelerated was the video? You say in real life that happens slower. So
Well, so for example, the compilation step to compile all of the functional suite at the moment is 8 minutes. Yeah, which is too long, and so we also want to find ways to improve that and reduce it. One of the things we actually are able to do right now is split things out granularly and run stuff in parallel. We actually just haven't turned that on because we don't have enough machines in the open to see that. So if I only have one AIX machine, actually I have 0, but I'm stealing the build machine. If I only have one and I say parallelize, run across a whole bunch of machines, it won't help me. So we delayed turning some of that stuff on, but I will like to see in the next few months to get some of that reduced. Yeah, so hopefully that answers your question. There's lots of other ways too. It's not just, the whole point of this conference and what excites me about seeing all of the different presentations is there's not just one solution to fixing the problem of testing. How do we run faster, right? There's tons of different things we can apply to this if we kind of open our minds up to new ideas. And, the notion of, can I not test? Maybe, actually, why not? Or can I reduce it so much that it feels like I'm not testing? I watched a very interesting presentation at another conference I was recently at where the fellow said, we were running 3 hours of testing and we made ourselves a goal to reduce our testing to 5 minutes. And he actually stepped it down and they got to about 15 minutes without reducing the coverage by a whole lot. So these are kind of some of the challenges that I want us to look at and see, maybe that's impossible, but if you don't set a goal for yourself, you're not going to get towards it. So, yeah, anyway, that's it. I think I'm keeping people from a break, so I'll be around for a bit if you have other questions. Thank you.
Thank you. So that's the end of the first session. We're going to pick it up again the second